Thank you all for joining in our 4th edition of the KQL Cafe. As always, your hosts are Johnny and myself. And the agenda for today is we will briefly talk about our poll results that we sent out to the community in the last weeks. We then have some updates on new things around KQL. And Johnny will talk about some things related to IoCs. And of course, as we try to bring everyone forward in learning KQL, today we will talk about another KQL operator. And then, with great pleasure, we will have Olaf Hartong with us. And then, as always, we'll talk a little bit about what we have done this month with KQL. So we did send out a poll request to get a little bit of feeling, how we ran the show. Of course, we received a lot of great feedback, but we wanted to know, things around the timing, duration, as well as the content. So luckily, you all responded that you're happy with Tuesday. So that means we'll continue to run the show on every month on the last Tuesday in the month, with the exception of July. So in July, we'll have a little summer break. Then in terms of timing, we understand that 2 hours is a lengthy time, especially since we run the KQL show around 6 Central European time. So some people might have families, dinner, and whatever. So we decided that we will try to reduce it down to 1 hour plus 15 minutes. Of course, without any warranty. If we are feeling good and we're going well, it might take longer, but we do our best. Then I was too lazy to break down all the results in detail, but I think this is what we expected. And yeah, thanks for giving us enough ideas and food to continue running the show. We understand that we have people that just start learning KQL, so we will continue to also work on the basics. But then also mainly focus on things like detection engineering, writing queries, optimizing queries, using external data as we did last time, etc. So thank you for all your feedback. So in this section of what's new, for those working with Microsoft 365 Defender, since about 2 years, we already had the opportunity to ingest raw Microsoft Defender for Endpoint logs into Microsoft Sentinel. You will do so maybe for various reasons, either because you would like to hunt beyond the 30-day limit that we have in Microsoft 365 Defender, or because maybe you have some compliance requirements. And lastly, as you use Microsoft Sentinel to maybe also ingest other data sources that go beyond the Microsoft 365 ecosystem, that would be another valid reason for taking that data into Microsoft Sentinel. Now, for many months, we have seen the coming soon logo, but finally, we have now basically all the Microsoft 365 Defender data sources available that we can ingest. So Microsoft Defender for Endpoints, Microsoft 365, when it comes to email information, email attachment, email URLs, email post, email post delivery table basically is not there yet. Then we have Cloud App Security. And lastly, long awaited the Microsoft Defender for Identity table. Now, the big question is always, what is this going to be in terms of gigabytes? Now, while for Microsoft 365 Defender for Endpoint a while ago, and I will add these details into the show notes, I wrote a query to basically come up with a formula, and I just ran it recently again, and I think unless you have a very busy environment, I think average, at least across my 10 clients where I run this query, I can say that each client will submit approximately between 6 and 10 megabytes per day. Now, when it comes to the other tables that we now also have available, like email, Defender for Identity, I probably have to use the consultant term, it depends. Nevertheless, I'm working hard across all the data sources that I have available to maybe come up with a certain formula, like, a number of emails per day that are coming in and out. Maybe that, will allow us to do some sizing. I'm pretty sure because the table is pretty static, in terms of the attributes. And maybe I'll try to do the same for Defender for Identity. Of course, you might always have outliers. As I have seen here in this environment, I noticed a very large increase in the identity directory events, and I was wondering why. And as always, what helps is to basically start looking at, what actions actually triggered those events, and how many do you have of those, and then maybe later even break it down in this case by, the source that actually triggered those events. And what we saw here, as you can see on the left, is that we had an enormous amount of SAM-R queries. And then when I broke them down, most of those were still attributed to the same system, unlike other systems. And well, long story short, this turned to be out a problem with some piece of monitoring software, on-prem monitoring software, that seems, to have some issues. And this now, became visible. Of course, we could have seen this maybe earlier already by doing the same in the Defender 365 hunting, but nobody did. But, as we now opened the gate to send those logs into Sentinel, we did so. And while on the Microsoft 365 Defender side, you might not care because you're not paying for storage there. But yeah, as soon as you bring that data into Microsoft Sentinel, it might be worth to keep an eye on that and remediate any issues. Then something more in the category of what's new. For those frequently working with log analytics, you might have noticed that we had a little UI glitch, which then was corrected. But yeah, previously, if you were crawling through your JSON represented data tables, when you wanted to extend a column using the UI, you would have to click on the three dots in front of the attribute. And now Microsoft makes it a little bit more convenient. So you basically just need to click on the attribute, click the right mouse, and then say, extend the column. So just in case for those that aren't here too frequently, next time you want to extend a column, this is how to do it. And then I hand it over to Johnny.
Yes. So let me share my screen. Share. Sharing yet. Let's see. Okay, share screen. Okay. Wrong screen. Share screen. Yes. Okay, so this month, working with IoCs. A couple of days ago, we had a new IoCs for the BlackCat ransomware. And last show we talked a bit about working with IoCs, and I think it's nice to repeat it a bit. So what we have done, we looked at the release, and in the PDF release, they reported that the FBI presented some IoCs regarding the BlackCat ransomware. So the idea is to use these kind of IoCs in your Sentinel environment or in your Defender environment. So to do that, I moved all the IoCs to a CSV. So we have all the IoCs from the PDF, and I produced a name column, a IoC column, and a type column, so that you can specify which items you would like to use. So when we go to advanced hunting over here, what I've done is you can, with the external data, you can import the list. You can even do a where type equals MD5 to get all the equals MD5. So now, for instance, we have all the MD5 hashes, and we can use it in the device file events or in the network events if you're looking for the IP data. We have this, then we can do a join on the device network events, for instance, on $left, which is the IOC. It is inner. Equals $right. And we can use the remote IP. And this is one way where you can use the IOCs from that specific report. And you can also, of course, do, for instance, if you get the device file events, where SHA-1 is in BlackCat. Once you had one of the SHA hashes on your network, you can it will return here. And this is a good and easy way to use these kind of reports if you want to do a quick check. Of course, you can also from the PDF grab the IP addresses and just use that in your Defender or in your Sentinel portal. And that way you can quickly verify if you have any issues you need to handle.
Let me add to that my personal recommendation. So whenever you build your own IOC lists, maybe consider adding a good known IP or a hash of a file that you have, placed in your system. so that you're really sure that, the query itself does work, that your file is correct. Because otherwise, if you're like me, full of typos, you might have a detection rule that might not even work, even if it would find something. So just my 2 cents to that. Yeah.
Good point. Of course, you can also import your CSVs. If you have them splitted, you can add them, of course, into Sentinel. So nowadays you can easily import in threat intelligence IP addresses or hashes or whatever you like. So you can or add them manually here one by one, or you can use the Sentinel APIs to import those into the Sentinel environment. Next slide. Another thing I wanted to talk about a bit today was the MV expand, because it's an easy operator where you which you can use in your detections or in your hunting. Every time you have a set of data which you or summarized or create a list or made a series, and you want to expand those or you want to see specific items, you can use the MV expand to expand your data. So for instance, if we go to Defender to the advanced hunting, no, we go to Sentinel. So over here, what I've done is I've created some queries based on the security alerts. And what I wanted to do is, first of all, I wanted to see all the security alerts in the last 30 days. And I wanted to see those to get a good view on which device IDs from Defender are creating the most incidents. So what I first did is I parsed the entities, but some entities had device IDs, some hadn't. So to better understand them, I wanted to expand this set so that you can easily get the items you want. So for instance, you have a host name over here, you have a process ID over here, some are empty. And that way you can easily search for it. And then an option would be to only display the items where it shows the MDATP device ID. So that's one option to search for it. And then you can extend the column based on the parsed entities and the MDATP device ID. And then you can use, for instance, the summarize accounts by device ID to see which device IDs or which device names name. Yeah, you have the host name. So let's extend hosts name. Host name. That way you can have an easy way to show which device IDs created the most alerts. Another option would be to use, instead of the parsing it and then expanding it. You can also do it to dynamic first and then expand it. And that's also a way instead of first way, you can parse it like this. And then if you want to only show the device IDs, then do a where is not empty. And then you have also all the lines with the device IDs. Another way where you can use it is if you do a make series for anomaly detection, for instance. You will also use it to expand the series. So over here in this query, what I've done is I looked back for the last 30 days, made timeframes of 3 hours. And what I'll do is get all the sign-in logs, and just to be sure where time generated, I go look back long. And now over here, I have all the sign-in logs in the range by blocks of the time frame based on user principal names. But now what you want to do is to make sure that you only get the items where you have a anomaly detected or where you have a high anomaly score. So to do that, you can also use the MV expand based on the time generated or on the score. And see, because now you only have the score, but still the rest is out. So what you want to do is you want to do it on all the columns. So not only the score, but also the time generated. And I want to see the sign-ins. I also want to see if there are anomalies detected. Anomalies score. Some reasons my columns are a bit off. Okay. So now we have all the records where you can easily search for it. Or you can also say where the sign-ins greater than 5. So you can use the MV expand to decompose your lists. And also if you make a set, you can use the sign-in logs where time generated ago, let's say for the last week. You can use a summarize, make lists, user principal name. Now you have a nice list of all the user principal names, and you can also use the MV expand to expand the list again. And that way you can work with your data. So if you're importing, for instance, data from another source, or if you are working with detection data, or if you have other queries which you or functions which you get the data from, then you can use the MV expand to expand the data. To the next slide. This one is for you again, Alex.
Yeah. You can leave on sharing because I'm not gonna. Oh, okay.
Oh, sorry.
No worries.
Okay.
Okay. Good. So, as for the KQL tool this month, yeah, Johnny and I were both a little bit busy, so I allowed myself to pull something I wrote actually 2 years ago, but maybe it comes in handy for one or the other. So the task here was, I want to hunt for specific PowerShell command flags. Now, as an example, in PowerSploit or any other, malicious PowerShell framework, you might have a lot of command flags. So rather manually creating those at that time, I basically created a PowerShell script that does a very simple thing. It reads all the command line names and then creates a query and stores that into a KQL file. So you see command line here. I posted the link here and I will add it to the show notes. So yeah, short little utility for creating KQL queries that are looking for command flags embedded in a PowerShell module. Great, and then we are very pleased to welcome Olaf Hartong. So Olaf, the stage is yours.
Thanks, guys. I'll take over the share there. Let's see if it works as expected. Yeah, there we go. Right. I saw it also in one of those slides you had earlier where people wanted to talk about time. I'm not sure if it's the same or, but in any case, hopefully it's interesting. I'll first introduce myself a little bit for the people that don't know me. My name is Olaf Hartong. I work for Falcon Force. This is a company in the Netherlands where I am a detection engineer, do security research. I'm a Microsoft MVP, and the rest you've probably read. So I build a lot of open source tools that you can find on GitHub, either my own or the Falcon Force one, where we also release regular Kusto queries as free hunting queries for people to utilize. But today we're going to be talking a little bit about time, and definitely not always on the great sense. So I primarily focus on Defender for Endpoint now, but similar stuff applies to Sentinel, as I'll also show you. So of course, everything should be logged in UTC, right? Or it didn't happen. That's at least what I usually proclaim. But that's the least of our worries, I guess. There's all kinds of other things that we have to take into consideration. And one of them is the ingestion of it, the delays maybe, that if you want to build custom detections or analytics in Sentinel, you have to factor in, because there might be blind spots there as a sort of small spoiler. So I try to visualize this a little bit, where I try to make it as simple as possible. Basically, what you would expect is you have some event happening on a machine, it gets flooded over the internet, it arrives in the Microsoft cloud a couple of seconds later, and everything's great. But that's, of course, not really what's happening. So what should happen, and this is, bear in mind, this is based on Defender for Endpoint. For Sentinel, it works slightly different depending on whichever transport mechanism you're using. But for Defender for Endpoint, basically what happens is an event is generated on a machine, whatever happens, like a process created or something else, that's stored in the buffer locally. And that depends a little bit. It's not a hard cutoff, but on average it's like between 5 and 20 minutes. And then it gets sent over the internet towards the Microsoft cloud in a blob. So basically they store up until a point that they have a certain size, and then they ship it over so that they do not flood the machine constantly with just 1 or 2 log entries. So the actual behavior is that sometimes there might be some congestion on the internet or your internal network or whatever's happening. You might not be connected, right? You might be in the train or driving home, and your PC might still have something running on it that might get ingested maybe even an hour later. These kind of things can happen. And this is where it gets tricky. So what I did is I wrote a query to basically see the average delay between the generated time and the time that it was ingested into Defender for Endpoint. And that's basically the query where you see above. I tried to comment it as much as possible because I'm not sure how your Custo skills are, but basically why I start out with a union, which is basically telling me, okay, give me every table, and the with source tables basically adds an additional field to that, which is the one on the left in the results, with basically the table where it came from. And then I only select the tables that start with device and end with events, because those are the most relevant for most of my detections. And it's good enough for the overview, and you don't need every table. And basically what I then do is I populate a new event or a new field with the ingestion time, which is a hidden field within the telemetry. You can just use it, but if you want to do some calculations on it, you can't use that ingestion underscore time with the parentheses behind it. It needs to be a field and not a function. And the next thing I do is I calculate the time difference in minutes between the ingested time and the generated time, which in Defender for Endpoint is the timestamp. And I populate that into the diff field, as you can see on line 8. Basically, then I only want to work with that just to keep the performance high. So I do a project and I toss away all the other fields. And the next thing I do is I do a summarize, where I first calculate the average difference. So that's the first. And then the second, I calculate the percentiles of the difference. And then I want to have the 75th up until the 99th percentile or per table. And basically sort it so it's more easily readable. And the interesting bit that you can see at the bottom is that there's quite some difference between even the ingestion of some of those tables. In the average is already quite far sparsed, where the file events are on average like 16.5 minutes, and the registry events can take up to an hour. And bear in mind, this is in a lab environment. But if we start looking at the averages, can be skewed, right? Because there might be some boxes that have been disconnected for a while and then start ingesting. So the more interesting bit is looking at the percentiles, because that's the rolling average, so to say. And then we can see that on the 97th percentile, there's almost similar delay. There's some tables that are sooner, some are later, but up until and then it starts raising for some reason. Especially for some tables. So we're trying to find a sweet spot just to see how much data do we need in order to cover the results that we want to get from a detection rule. And of course, we always have some blind spots, so we have to accept that. So in this case, probably if we look at the data for an hour, we already know that at the 97th percentile, we miss probably the half of it. Right, so that's something to keep in mind. If we transition this same query to a larger environment, which is actually not a lab, but a production environment with only over 60,000 endpoints, the results are quite different already. You can see that the percentiles are significantly higher. And this has all kinds of reasons, because people are moving about, they're not always online. So the delays shoot up as well. So if we now still look at the data for an hour in a query, we might see that the 97th percentile, we miss most of it actually, or almost everything. So at the 96th or 95th percentile, we actually are closer to a realistic result. That at least we have some data, and the 75th percentile is fine, right? It's 8 minutes, great. But then you miss 2/3 of your, or you only look at 2/3 of your data, basically. So we want to get to as close as possible to a full coverage. But looking at the 98th, that's quite a lot, right? So it's over 400 minutes sometimes. So that's quite far if you want to cover a detection rule that is actually running quite frequently to cover 98th percentile. But 97th might be possible. And I'll dig into how we're going to do that a little bit. But basically, to visualize it, why does it matter? If we run a query, that's the green bars every hour. That's what the least time is that you can do in Defender for Endpoint. We basically set it to the time generated of 1 hour. The event gets generated at a little over 1:30. It gets ingested at 1:47 or 2:47. And then we run our query, which basically, if we start it at 3 o'clock, it runs from 2 to 3 o'clock. But the event was generated at 1:30, so we don't see it. So that's an issue. However, if we, instead of the time generated that you see, so sort of at the top where the time generated is go 1 hour, if we do where ingestion time is over 1 hour, then we're fine, right? So that already is a significant improvement in terms of writing rules. And Microsoft actually partially agrees with this. The documentation got changed somewhere in July last year. However, 95% of the rules in their own repo and all public repos are still based on the timestamp or the generated time. And this is quite a problem if you're building detection rules. As you saw, most of the data is not immediately there, so you will create blind spots for yourself. So it's something to actually work with. For hunting, it's fine, right? Because then you usually look at larger data frames anyway. So if it's ingested half an hour later, it's still all right, because you probably look at data for a day or a week or a month sometimes, and then it doesn't impact you as much. But if you run queries every hour, your slot has moved on and you basically don't see it anymore. But this is also where they changed at least the documentation on the custom detection rules, that you should use the ingested time instead of the timestamp. So there's some things that we now need to know about how the custom detection rule scheduler works. And this is all documented, so I didn't invent this, fortunately. But if you schedule a rule for a specific time, so let's say an hour, then automatically what happens on the background is there is some custo prepended to your rule. So it's basically put in front of it where it looks for the data of twice that. So it looks for the data, the lookback time is set to 2 hours. So you always get 2 hours of telemetry if you run your query every hour. And this is based on the generated time. This is very important. And this is one of my pet peeves. So this has to change, I think, because this is still an issue. And this is also a case in Sentinel. And there are tickets for it, but I'm not sure how well they're addressed. And I'll show you why this is still an issue. And if you set it to 3 hours, the loopback time is 6, 12, 24. And if you set it to 24 hours, the loopback time is to 30 days, which is huge. So you don't want to definitely not use all that data. So if we have it on that hour, right, we have that 97th percentile, 96th percentile, somewhere in between. We at least can cover it with that 2 hours of data. So if we look at the ingestion time that I discussed before, we at least have most of the data in there. We still have some blind spots on the 97th percentile, but on the 96th percentile, you see it's almost an hour late, everything. And if you look at 2 hours of data, we still have it in there. So that's great. Next issue is that the Defender for Endpoint rule scheduler isn't very consistent. So if you set it to run, and it determines its own schedule, but it can be anything. So it can be 1 o'clock, but it can also be 1:05, and then the next run should be at 2:05. But what we found is that it isn't very exact. so to say. So if you set it to run for an hour, you would expect it to run every 60 minutes. However, if we start graphing this, we wrote a rule for it. Basically what we did, and I'll break up the slides for a second so I can show you, is basically we created a very simple alert where we just look at, hold on, I'll just extend it a bit. So it's having mind of its own. So basically we just get the oldest event that we can see within that hour. And basically look at the device events, merge that with the oldest timestamp and the current timestamp, and basically generate an alert. So every time we get the oldest event in that time frame that we have in that 2-hour box or that 2-hour loopback time, and we look at the time that it was ingested and the time that it was generated for the alert. So basically what we can then do is look at all the alerts over the past 30 days where the title is that alert that I generated, and then order them. And this is maybe an unfamiliar, and it's very hard to explain this scan operator actually, but it's basically a sort of if statement where you can iterate over a large data set, serialize it, and then populate it with the time difference that I can constantly calculate for every new iteration. So I can see the time difference between this event, and then the new time difference between this and that event. So I can stack them on top of each other, which is pretty awesome. It's a quite complicated set of documentation for the scan, and it still says preview on the documentation, even it's there for a year already. So I think it's fine. And basically what I do is I do a sort of iteration on all the differences. And then I look at, sometimes I run manual runs of the query as well. So I don't want to see those. And basically extend it with my expectancy. So I expect it to run every 60 minutes. And then basically if I generate a graph on the correct time frame, apologies, we can see that the expected schedule of the rule is actually 60 minutes. Which you set as well, right? An hour and 60 minutes. And we see that it maybe only happened once or twice in this period of, what is it, maybe 10, 12 days. And most of the time it's somewhere around 65 minutes on average. So again, that's an additional blind spot because there is data in between those two time frames. If I look at the data for an hour, I have something that I miss. I hope that they fix this soon. We also ran it on Sentinel. It looks a lot better. So we run 5 minutes alerts there because that's the shortest that we can achieve, apart from the streaming one, but that's out of scope. And there you can see that, well, the expectancy is 300 seconds. And then sometimes it's like, 302, 305. There are a couple of spikes, which I can't really explain, but it's like 23 seconds longer. But still, that's a lot less than several minutes that you might miss. So this is way easier to compensate for because you just if you want 5 minutes, you can look at the data for 10 minutes and then you're fine. You can even look at 6 minutes of data. So the scheduler on Sentinel is pretty decent. It's pretty good, but on Defender it's a little bit all over the place, as you can see. So this is something that we need to now start working with because there's all kinds of delays that we need to know. Apparently 65 minutes, right? Let's round it off a bit. So why not just look at that 2 hours of data every time, or 4 hours or 6 hours or whatever, how long your schedule is? Well, that's nice in your lab. That's fine. It works great. That's not that much data, but on that environment that I showed you before, that 65K endpoint box, you can see all kinds of bars showing up that Microsoft gets annoyed because we're using excessive resources, and that actually might give you new blind spots because you're in a shared resource pool. There are quotas there. So sometimes your other rules might not perfectly work, or you get all kinds of angry emails and notifications. So this is something you don't want to do. So we need to find a sort of perfect balance in between. And basically, what we can do, and an additional thing is if you look at 2 hours of data every hour, in the assumption that there is some delay, but not an hour, you will get some duplicate alerts, which is annoying because the SOC will hurt you. The MDE portal can sort of take care of that if the SOC isn't quick. So if you keep the alert open, it will merge it, as you can see in the screenshot. But if you don't do that, then you get a new alert again. So that also doesn't really work very well. So we need to do something with that as well. So we need to up our scope, but don't get duplicates. And this is where it gets a little bit more complicated. So we can definitely do this. We can what we did is we built a deduplication rule, which is a lot of engineering for a problem that shouldn't exist. But basically, what you can do is in Defender for Endpoint, you can query the alert info and the alert evidence tables, and look for the same results that you already found. So within your new query, and you run that every time. It's a minor overhead. So it should be fine. We didn't encounter any issues with this so far. The only slight issue here is that on the Defender side, you don't get all of the details that you get in an alert. So if the alert has multiple results, you only see the first one. So you can't be super exact in your deduplication. So for instance, if there were 3 processes that hit on your rule on that specific box in that specific time frame, you only see the first one as one of the results in your alert evidence table. And the other 2 are visual in the portal itself, but you can't query them within the custo tables. This has something to do that it is dynamic data and it can be appended and these kind of things, but I think it should be still possible to query that. It would be really nice because then the deduplication and these kind of things, you can all do all kinds of interesting research on this. So we are slightly limited, but it's not a real problem. And I'll tell you why in a second as well. So the deduplication can basically now only happen on the time and one of those impacted entities. So whether it's a machine, a user, or a mailbox, depending on where you want to deduplicate. On Sentinel, you're a lot more flexible, by the way. Then you can do whatever you like. So now it gets complicated a little bit, and then we're wrapping up because I don't want to blow your mind too much. But basically what we want to do is we want to prepend some stuff to our detection rule, and we want to append some stuff at the end. So basically what we want to do, if we want a rule that we run every hour, we set the time frame to 2 hours. As we know, that's the only data that we get. So this is what we need to work with. Then we define a rule ID where we want to deduplicate on later as well. So whatever you use within your naming convention, we usually use 4 digits, but this can be anything. And then we set the dedupe field, and we do this even though that it might be also that you want to do it by hand, but we template everything. So all of our rules are basically templated, and we have all kinds of stuff that we can then maintain on one spot, because that bit that we put at the end is static for that matter. So that's why we created a dedupe field, and we populate it with a device name, because let's pretend that we're building a rule that is looking for a device alert. Then we generate our detection logic. Can be anything that you want. Just make sure that you use the where ingestion time is longer than the time frame that we set, and not use the timestamp. And then we start building our deduplication logic. And this is where it gets a little bit iffy, because that's a little bit more complicated. But basically what we do is we look for the dedup field if it exists. And then we populate it. And if it doesn't, we populate it with not available. And then we start building the rest. So this is where we start looking at the alert info table, where the title within the same time frame as our rule ran, so that we know that we're looking at the same data, and where the title is the same or contains our rule ID, so we know we're looking at the same alert rule. And then we look at the evidence role should be impacted. That's just something that MDE adds to it. And the detection source should be a custom detection because we're building our own detections in this matter. And we trust that Microsoft deduplicates their own alerts. And then the next thing again is to make sure that the dedupe entry gets populated. Otherwise we remove it because then we also don't have anything to deduplicate on. And then we remove those if they're empty. And basically what we then do, and that's in the middle, we do an anti-join. So if we get results from the alert table, we do an anti-join on the results of our own rule. So we only get new stuff. And this is basically a very over-engineered way of looking at more data within the same time frame and don't get any duplicates. And the only reason that we have to do this is because there is, first of all, there is ingestion delay. So we don't know when data comes into our Defender portal or our Sentinel. And the other one is that we also have to compensate a little bit for that rule drift or that scheduler drift, that if it doesn't run every 60 minutes. So we need to always look at more data because we don't know when the last time was that it ran. Again, we can see it in the Defender portal, but we can't see it in the Custo tables. So basically, to wrap up, is whenever you're building your custom detections, make sure to use those ingestion times to filter your time frame. This at least makes sure that you're looking at the latest data and not something that could have happened a couple of days ago and you won't see it. Then make sure that you know in terms of how often you want to run your queries, how old your data is or what your ingestion delay is. But because you still have to keep in mind that if you run this every hour, you only get the data that was generated in the last 2 hours, even though it might be ingested a week before. That's something that will still be kept on the Microsoft side, and this is something we can't deal with, sadly. So the only thing that you can do with this is build 2 rules. One that runs every hour, just for the data that flows in nicely, and another one that runs every 24 hours, for instance, and then looks at the data of the last week, because you don't know what you have missed. So one of the things that I want at least the Defender team and the Sentinel team to fix is that to have that scheduler to run on the ingested time. So the lookback should be on the ingested time instead of the generated time, because then you always have the latest information. And it doesn't really matter when it was generated. You'll see that in your alert. And anyway, the data is still there. And they do this for their own EDR alerts by now. In the beginning, they didn't. I'm not sure if it was me or it was a coincidence, but I sent them an email about it that I found a bypass. And the next day, I got an email back that they couldn't reproduce it, and neither could I. So it appears to be fixable. So that was funny. So I hope they still do it for everybody, because this is just annoying that we have to over-engineer so much for something so simple. Yeah, and then if you're extending your time frame, make sure to deduplicate, because otherwise your colleagues will hate you. Or if you have to deal with the alert yourself, then you yeah, it's your own problem. But still, you won't like it. And probably something that I shouldn't even mention, but very important still, is to make sure to keep up to date with the best practices, because that will significantly help you in terms of performance. Some of the operators that you can use, I for some reason have contains as my default way of filtering, which is nice. But if you can make it that you can use a hash, for instance, it's way more performant, because that's just a quicker way of doing it. So these kind of little tricks might help you also improving the performance of your rules, especially if you do this at scale. We run hundreds of detections for our clients. You'll tend to see the difference in running times and performance benchmarks. So yeah, that was that. Thank you. If there's questions, there's a lot that I showed you, so I probably expect you need to digest it. So there's all kinds of contact details there. Feel free to reach out and shout at me or ask questions.
Yeah, so thank you, Olaf. There happened a lot on your slides. It was really awesome. And that's, like you said, some things to digest. I think we all learned a lot today. Thank you.
Yeah, it's not great news, but it's helpful news, hopefully.
It depends. And also, because now you showed it, now you can think of new ways to fix your detections. And also, for instance, I was thinking if you make your no, it won't work. Never mind. I wanted to say you can also filter your ingestion time in the last hour, but then you still have some scheduling issues. But
yeah, the problem remains that the lookback time that is sort of forced upon you by Microsoft is generated time and not ingested time, so that they cut off data that you still need. That's still a problem.
We have also a note in the chat. Andrew says thanks.
Yeah, and there's another one from Mr. Gimberg. How do you handle event time versus ingest time when correlating across devices for lateral movement? So what we generally do is we retrieve the ingested time, and if we want to correlate, we still do it on the event time because this is the time that it happened. The only problem there is not necessarily that's just an ingest problem. So you might have delays between those two devices as well, where one device is quicker than the other, and it might come into a other bucket. So the only benefit that you have with looking at that longer ingestion time bucket of 2 hours instead of 1 within your every hour, you still might get it, right? Unless it's so delayed that you still don't have it. But that's out of your hands then. That's a problem that you always have. But correlation should still be done indeed on event time. Good question, because otherwise you're looking at completely weird random event times. So this is just for filtering, looking at the right data.
And I have another question.
Yeah, go ahead.
If you look at the Defender timeline, that's also based on the timestamp and not on the ingestion time, right?
Yeah.
So if you're doing your threat hunting or if you have an incident response situation, then it can be that the timing is off, while it can be that it's right, but it's still, for instance, at one point I saw that there was a outbound connection, and after that there was like a sign in. Well, the sign in happened first and then the outbound connection, for instance.
Yeah, but then that might be due to system time. So that then another interesting thing that is slightly related to when we try to bypass stuff, we also noticed that there is now a new field added at the same point that I sent that email. So they added a process created time also to one of the to most of those events, where the process created time is the time that it was recorded on the machine. So that's the actual system time. The timestamp that you see is synced with the portal because Defender knows what time it is because it's also talking to Microsoft. And it trusts that time more than the system time. So the system time might be tampered with, and Defender still compensates for it, which is pretty awesome. So it not always works. If you set it too far back, it gets confused. And if you so it's not perfect, but they're trying to mitigate that bit a little bit to make sure that everything is in sync, at least on the ingested data bit. So if you look at the data, there's now 3 or 4 timestamps on average in an event. So you have to make sure which one you're looking at. It's slightly hidden, so it's not that confusing for most people just scrolling through the portal. But if you start looking at the schemas, then there's quite a lot more there.
Oh, thanks. Any other questions for Olaf? Any comments?
Yeah, Simon is speaking. Hi.
Hey, Simon.
I had this week a call with a customer. I migrated a customer from CrowdStrike to MDE, and they have nearly real-time dashboarding about what happens on the device. And the question came to the Microsoft product team: is there any SLA statement on exactly the ingestion diff? And there is not. And it's awesome to see your session today. So helping the project really.
Yeah, it's very different from what, for instance, CrowdStrike does indeed, right? Because they almost stream it. Defender made the decision to batch it, which is fine. I'm okay with that, but I'd like to have a known average, or that they say, because I also looked through the configuration. There is a buffer size configured, but there isn't a at least minimum upload period or something like it. So it does it when it feels like it. It looks like it. It's hard to put to wrap my hands around it. It's weird.
Yeah. But your session helped me really today with the customer project. Thanks for that.
Yeah, well, glad it helped. Most welcome.
We have another question by Frank in regards of the near real-time rules. Sure, if you played with that one already.
Well, that's still the same issue, because I think they for everything look at the generated time, not the ingest time necessarily. So then you might still have some issues. But I haven't played with the near real-time rules as much. So but it's a good point to look at. Correlating there will be extremely difficult, because then you just deal with the data that gets thrown at you at that moment. So it's nice for process creation and so on, and for maybe network connections, but for correlating lateral movement and these kind of things, I don't think it will be very, very stable. But apart from that, there shouldn't be a huge issue, because then it looks at the data that comes in. So if you look at certain singular events and don't do joins, then it should be fine. If you do joins with near real-time rules, if that's even possible, I'm not sure. What's that, Alex?
You cannot. There are some limitations on NRT rules. So first of all, you can only set up 20 in your tenant. Probably that's also probably not a technical limitation, but a limitation that they put in.
That's a resource limitation, I think, because in Splunk, a near real-time rule consumes a core. So then you consume 20 cores basically. So that's it's a cost issue.
I also did some testing recently because also if you look into Sentinel, into the updated analytic rules, you see that Microsoft is making proposals like, hey, there's an NRT for this and that. I so far in my lab environment, I wasn't able to get that break loss account, that huge difference between the NRT and the previously scheduled event. So I'm still playing and hammering on it with stopwatch and noting down timestamp and making notes because I really, before I tell all my customers like, oh, now let's move those important things to NRT. I believe the effort is only worth it if we can really demonstrate that huge difference. And right now, documentation says it's 1 minute, but you still have to add 1 more minute to it because it's basically 2 minutes, etc. The minimum for scheduled alerts is 5 minutes. So yeah, in the end, you maybe win 2 or 3 minutes.
Yeah, and honestly, if you don't have an extremely good automation engine tied to it, what's the difference then between like 2 minutes or 5 minutes? From my perspective, I also am very impatient and want everything fast, but there's hardly any SOC that is capable of responding within 5 minutes already. So For some events, it still makes sense, of course, but not for there's only for edge cases or fraud or these kind of things, probably where it makes a lot of sense.
Yeah. Well, the thing is, if you do an attack, then the initial compromise that can take a while. But once you got in, the action happens in a Bash script or in a Python or in a PowerShell, and that takes 3 minutes. So even though getting in takes a while, the actual action is, well, it's a script. So you want to have certain things fast, but then again, 2 minutes, 5 minutes. I think a SOC, if they respond and investigate and triage in 15 minutes, then they're on the good side of the clock.
Yeah, unless you have good automation, of course. So that might help. We also do a lot of red teaming, and I think it happened once when we got kicked off a box within 10 minutes. So that was super impressive. Doesn't happen a lot. Most of the time, they don't see it or see it late. So yeah, to your point, I agree. Any impact on parser functions? Yeah, it depends a little bit. Should you always use parameterized functions to avoid time issues? It really depends on the function, I think. So ideally, I try to write functions that are time independent, so you can use it on your data, whichever data you throw at it. If you have a time constraint on your function, then it might make sense to either add it as a parameter or have specific functions for specific time frames that you're querying. It depends a little bit on the use case, I guess. But yeah, ideally you make it as independent as possible. Parsers are less relevant, I think, because that has a time generated time in it. Or extracts it from it if you parse log data, I assume. So that shouldn't impact it.
Maybe in defense of my previous comment on the near real-time detection rules, I just looked up the documentation. They're still in preview, so maybe.
Okay. Sorry for the people that didn't have them yet. Yeah, and ASIM, I think it's the same. So ASIM is extracting the data that's there. So it extracts the generated time. So the parser itself isn't impacted, but the telemetry might be, depending on where it's coming from, how quick it's coming in, these kind of things. And that depends on how you're ingesting, I guess. So on the Sentinel side, it's still a big deal, because if you're ingesting, for instance, AWS logs, you run it every hour and you have a loopback of 2 hours. AWS usually does it only once every 4 hours. So maybe you get it, or maybe you don't then. So this is just, looking at your data helps a lot in terms of understanding where the delays are on average and how you can accommodate that in your detections.
Just thinking, because also ASIM is between the table and the analytic rules. So
yeah, technically it's a function. Yeah, but so the data is already in there. It has been ingested, so you have the ingested time tied to that already. And the time generated is also, the generated time is also there, because that comes out of that logic or the data itself.
yeah, but it's not messing extra things up, so to say.
No, it's probably making it easier, because the time frame or the time field's always the same, and there's a lot of benefits in ASIM. I kind of like it. I don't use it as much as I should probably, but it's also not complete yet. But it's a great step forward if you want to correlate multiple firewall data sets or even endpoint data sets.
Yeah, so this also explains The whole ingestion thing explains also why there's the timestamp always is like, it's always more or less the same dot milliseconds because it has its own batch processing.
Yeah.
Check. Nice.
Yeah, you definitely gave us all something to look
Homework.
into. To more detail. Great. So if there's no more questions, I suggest we head on.
Frank is typing one.
So somebody has to start, Frank. Yeah, it's I've had multiple discussions at clients, and they because we're only a tiny company, so we're taking bigger companies are taken more serious by Microsoft than smaller ones, as the world works. So some of my clients already created tickets to get this adjusted, because it's mostly, it shouldn't be our problem, I think, nor is it technically Microsoft's problem. It's something they can relatively easily fix.
Yeah, they just need to change time generated column to ingestion time column.
Yeah, from my limited knowledge, that should be the fix.
Right.
There might be other problems that then arise that I don't know about, but they also didn't respond to my email with that information, so I'm not sure. Yeah, this is not the async thing, so yeah, I can definitely email over, but he will forward it on to APM, and then hopefully it gets picked up. But then I'm in the same stream that I'm now. We'll see.
I'm thinking it's also because I knew about the ingestion time, but I never linked it to the blind spot, so to say. So
it took us a while as well, and this small talk took us quite some hours to get it right, and make sure that we don't. We still miss stuff, but it's 79 or 97% of the data we at least look at. So that's mostly acceptable. There's always something that you will miss. 100% would be nice, but that's never the case in anything. So I knew about this from other platforms, but I just forgot about it when I started working on Gusto, because all the examples were also there in that same way. So I just assumed that it worked, I guess. So that was also a hard learning lesson. Just never trust what you get, basically, is my sort of constant motto. I try to take apart everything to understand how it works and what I can gain from it.
I think one final question then, because you already showed your slides, and I heard, because we had a chat before, that you were working on a blog post.
Yep.
Is there something that you shared you can share with us, or share it on a blog post later, or share your Gusto queries that you used in your slides?
I'll probably release the blog post somewhere next week. And then everything is in there, and I can link the slides even to it if you want.
Cool. Awesome.
That's fine. That gives me some more time to write the show notes. or at least I have an excuse for delaying them.
You don't have to type over the recording.
Okay. Good. So thank you very much, Olaf. As some people told me ahead of the show, he's a legend.
That's a huge compliment.
Yeah, and I don't know when it was, but yes, I think since you guys started sharing your free hunting queries, I already got that feeling like, okay, they're a little bit above and beyond, writing those detections, but also, the way what you all get out of KQL, and that made you a perfect guest here. to also show that there are no limits. And I really also very much like the topic. Yeah. So thank you for being our guest, and
Thanks for inviting me. That's fun.
Maybe once we can say, okay, you were here in episode 4, we're now in episode 250.
I'll be back for that one. Yeah.
Okay.
Really noted.
Good. So let me continue with a little bit of what was done this month. So yeah, this is the easy part of these shows, because I basically just pick stuff I've been working on or are still working on, but I feel it's good enough to show. So one of the things I often like to do, or I need to do, is, okay, UI is nice, but customers and colleagues, they prefer to process data, and in order to process data in one way or the other, very often the first step is how to get it done in KQL. I guess here also sometimes, speaking of timing, you can set filters in the UI, and sometimes I try to get the exact same result. There's always a little deviation of maybe 1 or 2 machines or whatever, and I still haven't figured out that yet. But here I was able to basically create a very accurate representation of what we see on the software inventory, the vulnerabilities, and here is a query that basically does the same. I hope next time I can show you the next elevation of the script, because the whole reason why I started doing this is because some of our clients, little spoiler here, are using Patch My PC, but it could be any third-party patch management software. And I started that annoying work of creating a mapping table. And I don't know, since 30 years I'm in this business, and every company seems to have their own way how they name software or how they create abbreviations for them. Nevertheless, my effort was still way less than the many people that would have to do this manually. So I started this project in an early phase, starting out with Patch My PC, to basically link the Patch My PC software catalog to the Microsoft Threat and Vulnerability Management catalog, which then should allow people to kind of understand, okay, what software can we easily patch, and for what software do we still need to take an effort in building, update packages and whatsoever. So yeah, this is in progress. I'll share, the credit details in the show notes. Yeah, it's here. No rocket science. Okay, so the next one, actually, that took me quite some nights and hours and discussions, also with Johnny. So maybe also here right up front, yes, Microsoft is working on a Sentinel health feature that will allow you to monitor the data connectors. Nevertheless, that is still in preview, and currently it does only support a limited set of data connectors. And my client wanted to have this now. So the objective is, how can we identify whether someone intentionally or by mistake, or maybe there is a other issue, how can we identify whether one of the data connectors might not get any data anymore as we expected. So, I'm talking about these things when you have connected your data sources, be it Office 365, Azure Directory, Azure Activity, or whatever third-party data you get in. You always see here in the top, last in Office, we see it was 6 minutes ago, Azure Active Directory 5 minutes ago, Azure Activity 60 minutes. But this can be very different. Depending on the size of your company, whether you have an international company and people are living and breathing and computing around the clock, or whether everything shuts down at 5 p.m. If you're looking at the threat intelligence data, that heavily depends, for example, let's take the taxi connector, that depends on how you have scheduled your threat intelligence feeds import, where you can select every hour, every couple of hours, or once a day. And then on these connectors, sometimes those connectors do have multiple tables. So like we see here in Office, it's all Office activity, okay? In Azure Active Directory, we have sign-in logs, we have audit logs. In Azure Activity, it's called Azure Activity. And then, of course, in addition to the raw logs, we also have, security incidents, security alert, that we basically use for the ingestion of the alerts of the various platforms. Now, what I did explicitly, I made the difference between looking at alert tables and let's call it raw log tables, because alert tables, that's not very predictable. I mean, if you have a good day, maybe, no alert is coming in. So if you want to know, is my alert flow still working? I rather recommend to create a dummy alert. You can either create a scheduled alert in Sentinel. However, then, funny enough, we now also talk about time. You don't know really when it runs. So if you want to run it on a specific time, you would have to create maybe a playbook. But you can basically create a dummy alert, that allows people to see, okay, an alert will come in. But when it comes to data ingestion monitoring from the various solutions, I took the following approach. And it looks like this. And I will enlarge it in a second while I'm switching into sharing my other screen. Now, people make mistakes, and I made the same. So when I had almost finished my whole query thing, and I also used the union with source table command. And guess what a frustration I had when I had my first query and I wanted to put that into a Sentinel query, scheduled analytics rule. That doesn't work because unfortunately you cannot put create a analytics rule that starts with union with source. But maybe on the other hand, that was actually a good thing because it let me rethink the whole query, which is something I usually do anyway. I mean, when I finish my PowerShell work, I look at it and I think I can do it differently, and I start over. And the same now and then happens to my KQL exercises. So what am I doing here? I'm first creating a reference table to basically do a mapping of the, I call it data connector, to the logs. And the reason why I do that, because ideally, within every log table, it would have a very clear indicator from where to which connector it belongs to. But apparently that's not the case. You will notice yourself when you look into device events, you will not find something like Defender 365 connector, right? It will tell you, I'm coming from Defender for Endpoint as a data source, etc. When we look at some Azure tables, it will tell you something different. So to illustrate that, and of course I have to remove my stuff here. So okay, first of all, if I just used the query without the huge table here, I talk about that. But first of all, I specify which tables I'm interested in. I did the opposite with union with source. but that led me to rather end up with a similar thing in, removing tables I was not interested in. So I decided for transparency to go this way. I know what I want. I know what I want to look at. And then I take that data, and then I borrowed a script I found on one of the Microsoft document pages to look at the, last time generated thing. I do a project, and then I basically calculate the total entries in minutes, hours, and days, just so I have an overview. And here we can see in my lazy environment, that, okay, in average, data is pretty much coming in within hours. I can tell you in a real customer environment, you will see minutes here. Okay, so what you see here, let me see, where's the column? Project, resource type, where are you? Let's that thing again. Yeah, let's blend in this as well. So, and now you see a resource type, and unfortunately, oh, that's a mess. I don't have it in my environment here. But the reason why I had to basically use this reference table not only for the real table names, but also, as you can see here, this one is because if in a production environment you have Azure Firewall enabled, the thing is that Azure Firewall, Azure Key Vault, Azure Web Application, they all log into the same table. So, but I wanted to be more explicit, because if you go to your data connectors, where are you? Let's go here. This is what people expect to see, is that when they have their, Azure Firewall enabled, right? They want to see Azure Firewall, but as you can see, it's all Azure Diagnostics. If I go to Azure Key Vault, no, that's not the one. If I go to the Azure Web Application Firewall, you will see again, it's all Azure Diagnostics. So, and I want it to be more explicit. So I cheat a little bit, and I basically do a second join again over that very same table, but now I'm basically, looking at the resource type into a log table, and that then gives me the value of the connector name. That's basically a little cheating I'm doing. So going back, I can compare this, and that time pretty much, of course, this is UTC, but if we go to Azure here, we will notice the Azure activity timestamp is exactly, or almost as exactly, let me see, 5:48 p.m. and lost here, yeah, and here 3:48, but that's a 2 hours difference from UTC. Okay, great. Now we have this table. What do we do with it? Well, the next step was that I then went to my analytic rule, and I simply say, I'm going to create a connector health rule. And luckily, and of course I did test it before, but if I put a union somewhere here, it's fine for Sentinel. So I do an edit to show you how I did set up the query. Okay, Sentinel health, next one, here's my query. And then I do the same. I basically misuse the entity mapping. I just say cloud application, name, the name of the connector. I also have some custom details here, connector, table name. And yes, I could also start playing with alert details here. Connector health, if I were to decide to create an alert for each event. But now having deployed this to 2 or 3 customers, they all ask me, please leave it one incident. We're fine with it. But in theory, you can play with that if you like to have an individual alert for each connector. You can, of course, break it up. Then we have to look back the data. I run it in my demo environment every hour. And the result is then as following. If I go to incident, I go to my connector health alert. Here it is. And okay, these were my old ones. Yeah, here I have still played with the connector name. You see, I have the connector, Defender for Endpoint, and I have the connector and the tables that are not getting any data. Now this works fine, of course, as long as everything is a little bit in the same range. So as you can see here, I said, okay, where time is 4 hours in a production environment, you could probably put it, to even an hour because there's always something coming in. However, there are differences. I noticed in a production environment that maybe the key vault from Azure, maybe was silent for an hour or 2. So there's basically 2 solutions to it. Solution 1 is that you basically, copy paste the query and you just create a separate one and customize it so it meets, in more or less your time. Or option 2, this is what Alex is going to do now, is to have some more evening talks with Johnny, as he already pointed me to that direction, and to see, okay, can we maybe take some historical data and look at what is the expected average time, and then basically, I wouldn't have to hard code things here anymore, but basically, can use maybe an expected ingestion time and trigger an alert on that. I guess, that really depends on everybody's mileage, what he's after, or how precisely you want to have those things triggered. Yeah. Good. So yeah, that's what I've been working on in the last couple of days. And yes, it also taught me a lot about time and that sort of thing. So funny, Olaf, although not exactly the very same, but yeah, that we've been dealing with similar topics. Yeah. Good. Let me see where we are now. I think, yeah,
Alex,
we are just the slides.
Piotr is asking if you will share your KQL, but you'll probably post it on the GitHub, I guess.
Yeah, definitely. I will put everything into the show notes, and I will either put it into the KQLCafe GitHub, or you'll find me tweeting it and I'll share it via my GitHub. But everything will be there. We do this for the community, so there's nothing to be hidden here. Yeah. Good. So yeah, we had great intentions to run the shows shorter. I guess that didn't work out completely, but I had fun, and I think Olaf and Johnny as well, and I hope, of course, our guests in the show, and for all those that were online, you learned something, you enjoyed the time, and yeah, hopefully see you next time. We have some we continue to have awesome guests on our show. Next month we have, what's his name again? Roberto Rodriguez. Yeah. And then the month after we will have Mehmet, right?
Yes.
Yeah. And then I just got confirmation for our guest in August as well. So we will be updating that on our website, KQLCafe.com. Yeah. stay tuned for the show notes. As soon as Olaf has released his blog, I will complete the show notes. Johnny, as always, will finalize the video. So for those who couldn't make it live, the video, as always, will be posted on YouTube as well. Yeah, thanks for being with us, and see you next time. Bye.
Thanks a lot.